Hello everyone, Assalamu alaikum. This is the 7-week presentation of our Capstone project. This is group B3. I am Ishtiaq Hussain. Here is our group member, Mr. Tariqul Islam, Ishtiaq Hussain, Deepta Paul, Ashrafullah, and Atikul Islam Shajib. And our topic is fraud classification in high-dimensional imbalanced big data, which was supervised by Dr. Dewan Muhammad Farid. List of contents: fraud and fraudulent activities, imbalanced big data set, problem statement related to work, reason of choosing this project and data set. Throughout the presentation we will describe all of the things. Okay, first talk about fraud and fraudulent activities. So what is fraud? Fraud is an intentionally defective action designed to provide the perpetrator with an unlawful gain or to deny a right to a victim. There are many types of fraud like tax fraud, credit card fraud, wire fraud, securities fraud, and bankruptcy fraud. Okay, as our topic is on fraud classification in banking system, so let me discuss about some type of banking fraud. Okay, first one is over the shoulder looking scheme. Actually, it involves the offender observing his potential victim making financial transaction and recording the personal information used in this transaction. Another fraud system is phishing scheme. In this scheme, the system of 2 words password and phishing. Actually, in this thing, their social security number and the keys, their online banking username or password, they collect this. And another also have the Trojan horse scheme, identity theft, etc. Okay, let me talk about on imbalanced big data set. An imbalanced big data set is one where the number of observations belonging to one group or class is significantly higher than those belonging to the other classes. Okay, this is our problem statement. The fraudulent activities in this system or any sector, especially in financial sector, can be harmful to the owner of the system. Moreover, a fraud person can steal organization or personal information that can cause a privacy loss. So our target is to build a model that can identify a fraudulent activities and thus can classify a fraud in banking transactions. So our problem is actually imbalanced big data classification. Thank you everyone. This part will be continued Mr. Ashrafullah. That's all.
Hello, assalamu alaikum. My name is Ashrafullah from group B3. Our Capstone topic name is fraud classification in high dimensional imbalance big data under supervision of Dr. Dewan Farid. So I will talk about today. I had related work so far on this topic. First, imbalance big data classification, a distributed implementation of Smooth, which is published in ICDCN workshop 2018. In this paper, they present their algorithm observation and result for synthetic generation of minority class data under Spark using locality sensitivity hashing. In this paper, they mainly focus on implementing Smooth in an Apache Spark cluster using LSH and KNN. Second, implement intrusion detection on highly imbalanced big data using tree-based real-time intrusion detection system effects and solution, which is published in IJARC 2016. In this paper, they deal with analyzing the tree-based real-time intrusion detection technique for intrusion detection from highly imbalanced big data. Third, hybrid approaches for detecting credit card fraud, which is published in AME 2015. Fourth, minority report in fraud detection. Classification of skewed data, which is published in SIJKDD exploration in 2004. Thank you.
Hi, I'm Atikul Islam Shajib from group B3. Today I will discuss about why we want to do this project. The reason behind we do this project is that nowadays fraud person can steal organization or personal information that can cause a privacy loss. So our target to is build that can easily identify a fraud. Here there are some statistics. Value of annual online banking fraud losses in United Kingdom from 2010 to 2017 in million GBP. GBP is British pound sterling, the official currency of United Kingdom. Here there are 25%, 75% up to 150% is view million GBP. Here 2010 the rate is 63.7%, 2011 is 51.2%, 2012 the rate is 57%, 2013 the rate is 58.5%, and the highest rate which is 133.5 in 2015, and 2017 the rate is 121.4%. Now I will talk about the benefits to build this project. Fraud and robust model to identify fraud and fraudulent acts can prevent the stealing of thousands of crores of money. Thank you.
Assalamu alaikum. My name is Tariqul Islam. Now I am going to talk about the fraud detection process. In fraud detection process, we need data of past transactions, and then we need a model, machine learning model, and that model actually know the pattern or behavior of the fraudulent transactions. Then when this model is implemented in the system, then any transaction model will check this if it is match the fraudulent behavior or not. If it match the fraudulent behavior, then it will alert the customer that it's a fraud transaction. So to build this model, we need a data set. We already have collected our data set, and it is a big data, and total number of instances is about 6 million, and it has all 11 attributes, and the feature types are numerical and nominal, and we already analyzed the data set that there is no missing value. That's good news for us. But the bad news is this data set is highly imbalanced. Highly imbalanced means majority classes are non-fraudulent and only a few classes are fraud. And yes, so that there is only two class values. One is fraud and another is non-fraud, and the learning type is classification. There is a histogram of one of the feature called types, and it has 4 categories: cash in, cash out, debit, payment, and transfer. And our target class is fraud. 1 represent fraud and 0 represent non-fraud. And I told you that the data set is very imbalanced. Our outcome of analysis is there is total to 8,213 instances which are fraud, and the rest of 6 million instances are non-fraud. That's a very big challenge. Thank you, everyone.
Hello everyone. My teammate Ishtiaq Ahmed already told about the imbalanced dataset. In imbalanced dataset, the class with higher instances is known as majority class, and the class with lower instances is known as minority class. And the imbalance between the minority class and the majority class creates some challenges while dealing with highly imbalanced big data. If standard machine learning technique like decision tree and logistic regression is used, then these algorithms tend to show a bias towards the majority class, treating the minority class as a noise in the dataset. Thus, measuring the performance of the algorithm on imbalanced dataset is difficult, as in most of the cases it will try to predict only the majority class data. Thus, we come to a conclusion of methods of handling imbalanced dataset. One way we can do is improving the classification algorithm, and another way we can do is data pre-processing before starting the training. In data pre-processing, we actually follow two techniques. One is oversampling, and another one is undersampling. In undersampling, we can do random undersampling by just deleting some majority class instances. Thus, we can balance the dataset. And in oversampling, we can do random oversampling by just replicating the minority class instances, and thus we can make balance between the minority and majority class. And another technique we can follow is cluster-based oversampling. In cluster-based oversampling, the K-means clustering algorithm is independently applied to minority and majority class instances. Thus, we can identify a cluster in the dataset. Subsequently, each cluster is oversampled such that all clusters of the same class have an equal number of instances and all classes have the same size. And another technique is synthetic oversampling, which is also known as SMOT. In SMOT, a sample feature vector and its nearest neighbor is selected. Both of them actually belong to minority class. And then we take the difference between both of them and multiplies this difference with a random number between 0 and 1. And then a new sample is produced by adding the product with initial selected feature vector. And these are the references. Any question? Okay, then thank you.